Okay, in this lecture video, we're going to talk a little bit about what Vmax is. We've already discussed what Km means and how we talk about it. So Vmax is going to be the maximum rate the enzyme can turn over substrate. So when we say turn over substrate, we mean convert it to product. So it typically has units of micromoles of substrate per minute. That's how fast it's going. So we know from our little schematic cartoon we've been using, enzyme plus substrate to the enzyme substrate complex goes to enzyme plus product. We've said K2 is the limiting step, and so when K2 is the limiting step, we say that the maximum velocity is equal to K2 times the concentration of the total amount of enzyme. So we showed that in another one of the lecture videos. So that's the maximum rate that you can go. We're saying it's the total amount of enzyme because we're under conditions where the enzyme is completely saturated, so all of the enzyme is in the form of the enzyme substrate complex. So we also then are going to call K2 kcat, and that's going to be an observed rate constant. So let's take this a step further because we keep showing this really simplistic view of the enzyme process with only two steps, but often there are multiple steps. So for example, I could write enzyme plus a substrate going to the complex. Then I could go ahead and go back to the formation of product and then talk about product release. So here's K2. Here's now K3. We've got a third rate constant in here for release of the product. And it's often the case that product release is the rate limiting step. So kcat in this case would be K3. So the observed rate constant would be this third rate constant if that is indeed the rate limiting step. So the way we think of kcat then is that it's a function of the rate limiting steps, or the rate constants. It's a function of the rate constants that go with those rate limiting steps. We also call it the catalytic constant, and it's also called the turnover number. Okay, so it is the number of substrate molecules. So number of substrate molecules, so it's an actual number, converted to product in a given amount of time. In a given amount of time. Okay, so again, this is under conditions of substrate saturation of the enzyme. And this value of kcat that you measure is going to depend on the properties and reactions of all the enzyme complexes that are being formed. So kcat is going to have units also of inverse time, right? So it's going to be some number of molecules per inverse unit of time. So that means, therefore, that Vmax is going to be equal to kcat times the concentration of total enzyme. So before we were saying K2 because we were saying that the formation of product was the rate limiting step. By utilizing kcat instead, we're taking into account that there can be multiple steps in this enzymatic process. So now we can substitute in to the Michaelis-Menten equation to get a different form with some different kinetic parameters. So here is the original form, Km plus the concentration of substrate. So now, since Vmax is equal to kcat times E total, I can substitute in this term right here. So we also know that V0 is equal to kcat times the concentration of total amount of enzyme, concentration of substrate all over Km plus the concentration of substrate. So if you're doing some enzyme kinetics in a tube, you might know, in fact, the value of enzyme total. So you can get at some of these other parameters like kcat or the Km.